Throughout human history, the role of the physicist has been one of discovery, challenge, and interpretation. From the pioneering work of Isaac Newton to the reflections of Albert Einstein, physicists have been at the forefront of reshaping our understanding of the universe. With an insatiable curiosity, these researchers have tried to answer profound questions about the nature of reality, space, time, and matter. In recent years, one of the leading physicists in the field, Michio Kaku, has lent his voice to the growing evidence that our understanding of the universe is wronged. A theoretical physicist known for his ability to communicate complex scientific ideas to the public, Kaku has focused on discoveries made by the James Webb Space Telescope, JWST. A scientist of Japanese-American heritage, Kaku's contributions to quantum mechanics and classical experimental physics earned him recognition. His willingness to challenge established concepts and entertain new approaches has set him apart from the mainstream in the scientific community. Launched in December 2021, the James Webb Space Telescope is known as one of the most important astronomical instruments ever built. The successor to the Hubble Space Telescope, it was designed to see deeper into space and further back in time than any other telescope. Equipped with advanced infrared sensors, JWST can peer through clouds of cosmic dust to reveal galaxies and stars that formed a few 100 million years after the Big Bang. Excitement surrounding the JWST project was evident among the scientific community prior to launch. Many astronomers hoped the telescope would confirm much of what we already knew about the universe. However, to the surprise of many, discoveries have been made that could change our current models of global evolution. In these observations, we can point to the identity of 6 large galaxies that appear to have formed within 200 to 700 million years after the Big Bang. This is a surprising revelation because, according to the popular Big Bang theory, these massive structures should not have appeared at the beginning of the universe's history. The discovery of these 6 giant galaxies, which some scientists call universal space, poses a major challenge to the standard model of the universe. These galaxies are larger and brighter than our own Milky Way, indicating that they are forming stars at a faster rate. The fact that these galaxies came into existence shortly after the Big Bang contradicts previous assumptions about the stage of galaxy formation. According to previous theories, the early universe was a hot, dark place where matter was still mixing into the first stars and galaxies. Complex structures like galaxies were thought to take billions of years to form. However, the galaxies discovered by JWST suggest that this process may be faster than previously thought. This discovery has scattered the heads of many researchers. If these types of massive galaxies existed early in the universe's history, it raises fundamental questions about the nature of the universe and the validity of the Big Bang theory. Some have suggested that the universe may be older than we think. Some wonder if there is some unknown process at work that hastened the formation of these galaxies. Michio Kaku's reaction to JWST's findings was very enthusiastic. Unlike some of his skeptic colleagues, Kaku has always been open to the idea that our understanding of the world is wrong. He recognizes that scientific progress often comes from challenging established concepts and a willingness to entertain new ideas. In his public speaking, Kaku has emphasized the importance of empirical evidence in shaping our understanding of the world. He believes that the discoveries made by JWST could revolutionize our understanding of the evolution of the universe. However, he also admits that the findings will cause controversy in the scientific community. Kaku has observed that throughout history old theories have often been overturned by new evidence. He cites Einstein's theory of relativity as an example, which changed our understanding of space and time. Likewise, the discovery of these massive early galaxies will force scientists to rethink key aspects of the Big Bang theory and our understanding of the early universe. The Big Bang theory has been the dominant model of the origin of the universe for nearly a century. First proposed in 1927 by Belgian astronomer Georges Lemaitre, the theory states that the universe began as a sphere, a region of infinite density and temperature, and has been expanding ever since. This theory was supported by key observations, such as the microwave background radiation and the redshift of distant galaxies, which showed that the universe was expanding. However, JWST's discovery of 6 massive galaxies raises questions about the timing of the Big Bang theory. According to this theory, it takes billions of years for galaxies of this size and complexity to form. However, these galaxies appear to have formed only a few 100 million years after the Big Bang. This discrepancy has led some scientists to wonder if there is a gap in our understanding of the early universe. For one thing, the world may be older than we think. If the universe is old, it will take more time for these galaxies to form. However, this idea challenges the main tenets of the Big Bang Theory, which is based on the idea that the universe began about 13.8 billion years ago. Another possibility is that our models of galaxy formation are incomplete. Perhaps there is an unknown process that can accelerate the formation of galaxies in the early universe. Some scientists have speculated that dark matter or dark energy, two mysterious substances that make up most of the mass and energy of the universe, may play a role in this process. However, these ideas still exist. However, JWST's discovery of 6 giant galaxies has led some scientists to question the reliability of redshift as a measure of the distance to the universe. Although redshift is a powerful tool, it is not a limitation. Small errors in redshift measurements can lead to large differences in our understanding of the age and structure of the universe. Some researchers believe that JWST's surprising findings are the result of these errors. Some argue that the redshift data are accurate and that the detection of these massive galaxies poses a serious challenge to our models of the universe. Beyond scientific methods, JWST's findings also raise important philosophical questions about the nature of science and the practice of science. Throughout history, scientific methods have changed in response to new evidence and discoveries. What was once considered settled science can now be overturned by discovery. This process of continuous evaluation and re-evaluation is a very characteristic feature of scientific progress. JWST's discovery of 6 giant galaxies challenges one of the most established theories in modern astronomy. This forces scientists to rethink their ideas about the place of formation of galaxies and the first universe. This isn't the first time a major scientific theory has been challenged by new evidence, and it won't be the last. For example, in the 17th century, the heliocentric model of the solar system, which stated that the Earth and other planets revolved around the Sun, was strongly opposed by the scientific establishment of the time. The geocentric model, which held that the Earth was the center of the universe, was the dominant view for centuries. But as new evidence accumulated, the heliocentric model was finally accepted, changing our understanding of the universe. Likewise, the discovery of 6 giant galaxies may represent a paradigm shift in our understanding of the universe. It challenges conventional wisdom and forces scientists to think that the universe is more complex and mysterious than we previously thought. The discovery of these early massive galaxies by the James Webb Space Telescope continues to challenge not only our understanding of cosmic evolution, but also the broader scientific framework that underpins modern astrophysics. As more data emerges, it is increasingly clear that the universe's timeline may be far more complex and nuanced than previously believed. These findings push the boundaries of theoretical physics and cosmology, inviting scientists to explore alternative models and reconsider the fundamental principles governing the universe's origins. The rapid growth and organization of these galaxies suggests that the early universe may have been far more dynamic, with conditions that favored the accelerated formation of stars and galaxies. As humanity looks toward future discoveries, the profound implications of these findings remind us that science is an ever-evolving journey, driven by curiosity, evidence, and a willingness to rethink established ideas. The continued exploration of these galaxies, along with the technological advancements that make such discoveries possible, holds the promise of unlocking new and transformative insights into the workings of the cosmos.